Hello, welcome back to Math 8. This is a video over Unit 7, and we're going to be talking about Section 7 today, which is about dilations. And so today we want to use proportional reasoning to determine if one figure is a dilation of another, determine the scale factor of a dilation, determine the result of a dilation given a center of a dilation, and the scale factor. So a dilation, remember, is when something gets bigger or smaller. So gets big or small, okay? And so a dilation is a type of transformation that changes the size of the pre-image. The pre-image and image are similar figures. So talking about similar figures, what I like to say is that they are the same shape but different size, okay? And so one thing I like to think of, if we can think of examples of similar figures, what I like to think of is like an actual car to a toy car. Okay, they're the same shape, they're the same, overall dimensions. They're just modified by a scale factor. Okay, I like to think of a map in the actual size of like the city or state. Okay. Another thing to think of is like a globe. All right. So a globe is a scaled down version of the Earth. All right. And there's a number of examples, but that word scaled drawing and all those kinds of things are really just examples of a dilation. Okay. And so you can think of this as like your pre-image, and this is your image, okay? And all you're doing is you're going from one to the other and you're getting bigger, okay? And you can also get smaller too, it doesn't matter. So let's talk about those types of dilations. Okay, you can talk about a dilation where you have an enlargement, okay? So the image, the result, is larger than the pre-image, okay? And this happens when your scale factor is larger than 1. So when n is larger than 1, okay? And then a reduction means that your pre-image is smaller, or the image is smaller than your pre-image, okay? And that's when your scale factor is between 0 and 1, okay? So your scale factor, and I use the value for n, so let's write that your scale factor is n. And we'll talk about more about what the scale factor is and how that works. But here your scale factor is greater than 1, meaning it's going to get bigger. Your scale factor is between 0 and 1. Essentially, that's going to make it smaller. Okay, so similar figures are figures with congruent corresponding angles and proportional corresponding sides, okay? So here we have two squares, okay? All right, and one of these, what I can say is that, this side here corresponds with this side here, all right? And similarly, because it's a square, it's kind of hard to see, but that's the idea, is that these sides are going to correspond with each other, okay? And what, we can talk about the congruent corresponding angles. All of my angles in this figure, in my square, are going to be 90-degree angles. All of the angles in this figure are also going to be 90-degree angles, okay? So angles are congruent, okay, from one to the other. Now, when we talk about proportional corresponding sides, proportional, let's talk about what that word means. So proportional means I have equal fractions, okay? So equal fractions. And what I want to do is I want to go from my big to small. And so if I take 6 and divide that number by three, okay, that's going to be equivalent to me taking 6 divided by 3 on that. So I've taken, my corresponding sides, 6 divided by 3 is equivalent to taking this 6 divided by 3, okay? And we know that, 6 divided by 3 is going to give me 2, and 2 is going to be equivalent to 2, okay? And so doing that actually is going to tell me what my scale factor is, okay? And so the scale factor of a dilation measures how much larger or smaller the image is for a dilation. The scale factor equals the ratio of corresponding sides. So there's a couple different ways of looking at this. The scale factor here, n, was equal to 2, okay? And so one way that we can do this is take the length of the image and divide it by the pre-image, okay? And I use my scale factor. I'm going to use the variable n to talk about my scale factor. That's pretty standard for all mathematics to use n as that variable, okay? So what I want to do is look at a couple of things here. Let's label our corresponding sides. So 10 is going to correspond with 15, okay? And I know that because they're both the largest side, okay? So 10 is the largest side of this triangle. 15 is the largest side of this triangle. I know that 6 is going to correspond with 9. 6 is my smallest side over here. 9 is my smallest side over here. Lastly, I'm going to have 8 and 12. And 8 and 12 are going to be the middle length. Okay, so that's how I figure that out. What corresponds with what determines on the size of one to the other. Okay, so what I want to do is figure out our scale factor from here. Okay, now we want to take any value of our image and divide it by the corresponding side of our pre-image. So one way that I could do this to find n is I could do 15 divided by 10, okay? And that's going to give me a value of 1.5, okay? Now, I could also do 9 divided by 6, okay? If I do that division, I'm going to get 1.5 as a result, okay? Lastly, if I look at this and I say, all right, well, let's do, n is equal to 12 divided by 8, all right, that's going to give me the same thing, value of 1.5, okay? So my scale factor in this example is equal to 1.5, okay? Now the other thing that I can do, the way that I always learned this was you can choose any number from your pre-image. I'm going to use 10 and 15. And what I do is I do this. I say, okay, I'm going to take some number 10, and I'm going to multiply it by my scale factor n, and I get 15 as a result, okay? So you can set this up any which way. You can say 6 times some number n gives you 9. You can say 8 times some number gives you 12. Doesn't matter. That's how I always thought about it, and then you solve this equation to figure that out. And so you divide both sides by 10, and you end up getting the same thing that you had up here, and you can solve for n and get 1.5, okay? But that's how we look at scale factors. That's how we figure out what the scale factor is. And again, this scale factor is larger than 1. So therefore, I take each of these sides and I multiply it by 1.5, and it gives me my new image, okay? And so notice how you take this, your scale factor was larger than 1, so you got bigger, all right? And that's the idea. So, all right, let's take a look at the next page. Okay, we've already talked about this. Facts about scale factors. You can either reduce or enlarge them. If you're less than 1, you get a reduction. If you're greater than 1, you produce an enlargement. Equal to 1 means that you just get congruent images, and you're not going to have a dilation. And if you have a scale factor that's equal to 0, that's not going to give you anything. So that's why when you had a reduction, you wanted to have a value n that was larger than 0, but at the same time was also smaller than 1. Okay? And something that produces an enlargement, you wanted a scale factor that was larger than 1. okay? Now, we have, when we do these, we have centers of dilations, okay? So every dilation has a center, okay? So each point on the pre-image moves along a ray that begins at the center, okay? So what we want to do is this, is apply our scale factor and the center of dilation, okay? And so looking at a scale factor and center of dilation helps us figure out what these lengths are and what our scale factor is. So let's just think of an example. Let's say that OA in this example is a length of 2, okay? So I'm going to label this length here as 2, okay? And then what I want to do is, let's say that my scale factor n is equal to 3, all right? So what we do is we take the length of OA and we're going to multiply that length by 3, and that gives us a new length. And so let's do that. We've got 3 times 2, so n times OA, so 3 times 2 is going to give us a total length of 6. So then we have this new length, and that new length is OA prime. So OA prime is equal to a length of 6, okay? Now, we can also do something where it gets smaller, okay? Down here, let's say that OB is let's say a length of 4, okay? And let's say that our scale factor has a value of 1/2, okay? So what I'm going to do here is we're going to take the original length of OB, okay? And that original length is 4, okay? And we're going to multiply it by our scale factor, which is 1/2, and half of 4 is going to give us a length of 2. So OB prime has a length, and let's do that here. OB prime has a length of 2, okay? So that's the idea, all right? So, and you can use this information and set up this equation to find the scale factor, okay? And here's what I'm going to do. I want to find the scale factor. Here's what I know. That O is my center, okay? And if I take my original length, which is OP, and I multiply it by my scale factor n, that's going to give me a length of OP prime. So OP has a length of 2. I don't know what my scale factor is. That's what I'm trying to find. But it gives me a total length from OP prime, which is a length of 8. And I can set up this equation much like I had before and divide both sides by 2, and I get that my scale factor is equal to 8, okay? And again, if you wanted to find your scale factor n, you could take your image, divide it by your pre-image, and that will give you the same thing, all right? You're doing the same thing, it's just 2 different ways of looking at it. But my image, the result of me dilating this, is a length of 8, okay? And we're going to divide it by our pre-image, which is 2. Whoops, this should give us a scale factor of 4, not 8. I don't know what I'm doing. Okay, so scale factor is 4, sorry. 8 over 2 gives you 4 as well. Okay, so that's the idea on that. All right, let's take a look at the last page. All right, so the next thing we want to do is construct a dilation. So to dilate any figure about a center, we want to draw a ray that extends from the center, so here's my center, through each point of the figure. So from 0 to A, 0 to C, not 0, O to B, okay? Use the scale factor to then plot the points of the image on each ray. So I'm going to take this length, multiply it by my scale factor n to give me the total length, put A here, and I'm going to do that for all of these, okay? And then you connect the vertices here and you get your new dilated figure. So let's take a look. Let's try this on this one. So what we want to do is we want to take this line segment AB and we want to dilate it by a scale factor of 2, about the center 0, okay? So again, you know, we've already done this. We've drawn the rays for OA and OB, okay? And so as a result, what I want to do is I'm going to take OB, the length of that, multiply it by 2, and that's going to give me OB prime, okay? I'm going to take the length of OA, multiply that by 2, and that's going to give me OA prime, okay? So this length here, which, you know, we can really call that whatever we want, but what I'm going to do is I'm going to, you know, let's say that this is a length of 3, okay? Then I want to extend this out another length of 3 and plot my point B prime. Same thing down here. Let's say this is a length of 2, and I want to extend this out by another length of 2 to get the point A prime. Okay, and think about it. 3 times 2 should give you 6. So if this length here was also 3, the whole thing is 6. Same thing down here. If that is 2 and that's 2, the whole length should be 4. All right, and then we connect our points from A prime to B prime and draw that segment, okay? So let's say that, you know, whatever length this segment was, all right, let's say that, you know, the length from A to B is a length of 4, and I'm just making numbers up, okay? I'm not doing anything crazy. Then the length from A prime to B prime should be a length of 8, okay? And that's the idea, and understanding what you're doing to this to get this, but being able to draw a picture of it requires you to have a center of dilation, okay? All right, let's take a look at this, and let's, you know, on this one it says dilate triangle ABC, okay, about the center O by a scale factor of 1/2, okay? So what I want to do is cut each of these lengths in half and plot new points, and we're just going to eyeball it, all right? But C, let's start with point C. Okay, if I cut that point in half, it's going to be something right about here. We're going to call this C prime. A prime, cut that in half, is going to give me a point here, A prime. And then B prime, this one's a little harder to see, right about here, B prime. Okay, and then I connect my points to get that dilated image. All right, and the goal is that, you know, mine's not perfect, but like C prime to A prime really should be parallel lines with each other. Same thing with CB and C prime B prime. Same thing with AB and A prime B prime. So that's the idea. So hopefully you enjoyed this video, and we'll talk to you soon. Bye!